Okay, so now we're on page 96, and I'm going to do a few at a time here. Okay, so on page 96, we're going to look at number 1. It says magnesium bromide, so you should know what magnesium bromide is. So we know it's Mg2+, bromide is a -1, so it's MgBr2 plus chlorine. Is that correct? What do we know about chlorine? It's a halogen. It has to be diatomic because it has to react with itself to stay stable. It's that unstable. Okay. So this right here is a single replacement reaction because this wants to displace this to form products. Now, can we say for sure that's going to happen? No. What do we have to do? Go back to our activity series. So you go back to page 94 and you see here's your nonmetal. You always want to have a metal, nonmetal. You want to have a nonmetal over here, diatomic nonmetal, and you want a metal, nonmetal here. Does this nonmetal have enough energy to break this apart and displace bromine? So when you look at page 94, you'll see diatomic chlorine is more active than bromine. So yes, this guy's going to come in here and go break that sucker apart. So you have some magnesium ions here, atoms, excuse me. Bromine and chlorine. Now, will some of it go back to magnesium bromide and diatomic chlorine? Yes, absolutely. Some of it will reverse backwards. Again, what if I don't have much of this? Then this will come back. Do you understand what I'm saying? Like, that's going to be stoichiometry, next level. But what could be formed here? So we see that we have diatomic bromine. So over here, we're going to put bromine by itself over here. Just like that. And then we have to know magnesium chloride, MgCl2. How do you get MgCl2? You have to know it's Mg2+, Cl negative, Cl, you know how to do that. Okay. Second one, aluminum, Al. And it doesn't need to be diatomic because it's in group 13. Iron 3 oxide, so we know it's iron 3 oxide. So it's going to be plus Fe2O3. You should know that fast. And if you don't, and you got issues with this, then you're wasting your time in this class. Okay. So now, we're going to ask ourselves, this is single replacement. Does aluminum have enough energy to go in? And where does it want to attack? The oxygen or the iron? It wants to attack its own kind because eventually it wants to form an ionic compound. So does it have enough energy to attack the iron to eventually form an ionic compound? So you go, in your mind you should think yes, but double check. Aluminum has more energy than iron. Not by much, but it does. So this can come in, break that sucker apart. So now you've got aluminum. Now you should know this is an Fe3+. But it really is not going to matter much. Just in the back of your mind. And you've got oxygen here. So now will all of it become, watch this. So this iron is going to be what? By itself. It can exist, it's a transition metal by itself. Okay? Well, what about aluminum? Aluminum has a charge of 3+. Oxygen is 2 negative. You know you're going to get aluminum oxide. Al2O3. So again, when we take a look at something like this, right? And when you go back, will this whole thing form? Yeah, that'll form. Will some of the aluminum stay by itself? Will some of the iron and oxygen react? Absolutely. But the majority of it will turn into this, okay? But again, we can predict how much. That'll be next level, okay? So that's number 2. I want you to go down to number 5. Zinc plus hydrochloric acid. Okay, so again, you have to know all this information. Okay, so now I will tell you right now, in your mind, this is single replacement. I don't have to look at the chart, but you will, it'll help. Anytime you add a strong acid to a metal, bubbles come off. Bubbles will come off because that's hydrogen gas that's being produced. So I will tell you it works, but let's take a look. So again, So here's the situation. We know hydrogen is a gas. We know we have here, we have a situation where the substance dissociates. So it's an acid. So this is a little bit different. It's not just a metal. Does zinc have more energy than hydrogen? Can zinc go in here and attack the hydrogen and break it apart? And you will look at your chart and the answer is absolutely it does. It's over hydrogen on that chart. So when you break it apart, you've got zinc atoms, and zinc has an oxidation number of +2. You're going to have to go back to your transition metal list. Hydrogen, and you've got Cl negative, chloride ions. So who's going to go together? You're going to have diatomic hydrogen, again Brinkelhoff, and then you're going to have zinc chloride, the salt. Zn 2 plus Cl negative, just like that. So once again, single replacement reaction. Okay? Let's go to number, let's see, no. Let's do, I'm trying to look at ones that you could do at this, but that are single replacement. I just want to do single replacement. Go to 14. Don't worry, we'll be doing the other ones soon. Take a look at 14. You've got lead plus zinc chloride. Okay, why don't you try it? Take a minute, pause it, and try it. Okay, so you should have tried it. So overall, we've got lead, zinc chloride. Who does it want to attack? We want to form a metal nonmetal. So this guy's going to try to attack its own, the metal. Can it do that? Well, I have to even look it up. So you go back to 94. Lead is, compared to zinc, lead is below zinc on the activity series. This doesn't have as much energy as zinc. Therefore, these will not react. You put a no reaction right there. Okay, so that is a no reaction. All right, so the other single replacements I want you to try that are on page 97. Oh gosh, there's only one more. Okay, that's fine. You're going to do number 20. Actually, we'll just do it together. What the heck? I just want you to learn it. Let's do 20. You have enough to practice. Don't worry. Calcium plus water. Okay. So now hydrogen is a little different. Does calcium have enough energy to displace hydrogen from oxygen to mess the water up? And the answer is going to be absolutely. Calcium is a very active metal. So what happens is this comes in, breaks apart. So now you've got calcium atoms running around that want to form this 2+ charge. You've got oxygen atoms that run around that want to form that 2- charge. And you've got hydrogen atoms running around. So you know you can have diatomic hydrogen, and you have metal nonmetal. C EOA, done. CaO plus H2O. Okay? So that was from page 90, let's see, 6 and 97, some of the single replacement reactions, okay, using the activity series. So hopefully this helps you guys. Okay.